And welcome to the Daily Space Weather. Smasho here coming at you from the Smash News Network, least busted name in news. It's been an exciting 24 hours in the solar system, especially if you're paying attention to things like space weather. So, yeah, great imagery today. Lots of filaments, lots of flaring, lots of sunspots, an expected increase in the radio flux, plenty more to cover. Let's take a little trip to look at a bunch of filaments. So huge crown prominence right now suspended by the magnetic fields around the North Solar Polar region. And let's go around the horn clockwise. So we've got a little bit of shrinkage of this sunspot group here, a little bit of growth of this sunspot group down here. Overall, we're going to see an uptick in the sunspot number and likely also the radial flux throughout the day today. The Hulk Hogan prominence, well, it's about to become a prominence. This huge filament down here is still hanging out. Giant solar filament there, very visible in these wavelengths, 304 plus 193 angstroms. Of course, the most activity is this giant sunspot right here. It's not only huge, it's very magnetically complex. It's actually grown since yesterday also. That should cause a further increase in the sunspot number as those sunspots get added to the sunspot count. And here's just the northeastern limb. Yeah, likelihood of major coronal mass ejections and even X-class solar flares is certainly quite high. So here's yesterday plus today. Again, this group up here has lost a few sunspots. This group down here has gained a few sunspots. And this group over here and this one, again, will add massively to the sunspot number today. Sunspot number will be approaching, 200. There is your colorized magnetogram from SDO. And let's see what's going on Croissant Earth. So first of all, the Halema Uma'u lava lake is still erupting. The Kilauea volcano. That is the Halema Uma'u lava lake there, featured in the thermal imagery. The eastern portion remains stable here, suggesting a delicate equilibrium between heat and magma supply and loss, so-called drain back. Popocatépetl exploding in central Mexico, flight level 240. It's producing a 24,000-foot plume of volcanic ash. Fuego in Guatemala exploding, also flight level 150. Volcanian and Strombolian activity there. It's a 15,000-foot volcanic ash plume. Nevado del Ruiz exploding, flight level 200 over Colombia. Flight level 190 over Sangay in Ecuador. It's a 19,000-foot ash plume. 15,000-foot ash plume over Revenador in that same nation. Flight level 150. Flight level 210 over Cotopaxi as it explodes. Sabancaya intermittent puffs over Peru. And Villarrica exhibiting Strombolian activity. Please remember to not pole vault the caldera. Leave that off of your list of things to do. And looking at global seismicity here, it's been quite calm over the past 24 hours. Quite a low number of earthquakes. And also no major earthquakes. That's the 90-day bar graph. And here is your USGS site. I believe there is only one quake over a 5 magnitude in the past 24 hours. So again, a low number of quakes and low intensity quakes. There you go, a 5.0 at the South Sandwich Islands. That was the largest earthquake of the past 24 hours. So a big lull in seismic activity here following a big uptick. And we'll just let the list scroll here, and we're going to return back to space in just a moment. First, take a moment to press the like button. Now, if we receive 50 likes on this calendar date, on this video, we will do a live stream later today, Q&A session, news crawl, whatever you want to do. We'll let you, the viewer, steer the video somewhat. One of the links you can find below the video is the link to our Redbubble shop. So if you click the description below the video, you'll find our Redbubble products in order of best selling. These may or may not reflect the views of the Smash News Network, least busted name in news. We decided to put out a lot of different products because reasons, and congratulations on surviving a global pandemic so far. Today's featured product is Do Not Pole Vault the Caldera. It is our best seller, and it's a public service message brought to you at massive personal risk and expense by Smash staff and I. If you're going on a volcanic vacation, leave your vault pole at home and don't pole vault the caldera. It could be unhealthful. And we need the views on YouTube. Again, press that like button if you haven't done so. Yesterday's video had over 100 views, but less than 50 likes. So do your part, especially if you'd like to see us actually do a live stream on YouTube for once. We'll consider it this afternoon if we see 50 likes. So pick up some merch, support the channel that way. Press the like button, press subscribe, share, etc. Leave a comment, tell your friends and foes about the channel. Thanks to everybody who has picked up merch the past several years. We've also got a Patreon, by the way. You can support the channel that way. 3 membership levels available there. And the best way to support the channel is via a Smash Team membership. So smashomash.com/Smash Team is the official subscription services site of the Smash News Network, least busted name in news. If you enjoy the content and you'd like to see it continue to remain publicly visible and free for all to view, help support the channel, because the likelihood of it remaining publicly visible and free for all to view drops daily. Yes. So, yeah, thanks to the Smash Team members, there's a gold, there's a silver, there's a gold annual paid-up subscription. There's even a bronze level that doesn't even require you to open your cobweb-encrusted wallets. Smashomash.com/Smash Team. Links to social media there as well. And let's get back to space. Perhaps our new favorite composite wavelength here. 131 plus 171 angstroms. Great imagery there from SDO. Let's take a brief look in 304 angstroms, the classic ionized helium wavelength. A lot of activity showing up there in the eastern limb, also in the northwest, even some activity in the southwest. Lots of activity, period. The 10.7 centimeter radio flux now at 215 solar flux units. So yeah, radio flux definitely exceeding 200 as we forecasted yesterday, and you can expect it to go even higher today because we've got another major sunspot group there, especially in the southeastern limb. At the moment, that's the current situation. That's a 1-year graph. The black line is the 10.7 centimeter radio flux, and the red line is the sunspot number. Continuing on to our space weather enthusiast dashboard here, and NOAA did a fine job here forecasting a little bit of geomagnetic unrest. It happened almost on time there, a little bit later than expected, but not bad. Not bad at all. A little bit of geomagnetic unrest happened. In fact, we saw a geomagnetic storm, and it was exactly what they forecasted. A 4.67 is exactly what we saw. So that was actually a little bit earlier than expected there. So that happened just before midnight last night, between 2100 and 2400 Universal Time. Next, looking at the last 4 hours of Earth's magnetic moment from space. The Space Weather Modeling Framework Geospace Magnetosphere movie depicts magnetohydrodynamic pressure. And that is croissant Earth. That's part of the reason why we call it croissant Earth. You know, the funniest jokes are the ones that are true. Earth, it's croissant shaped. No, for real. Now, extrapolating the flat planet, the croissant-shaped planet, onto a flat rectangle. This is Earth's magnetic moment from the ground. The units depicted here are nanotesla magnetic flux density. That's the last 4 hours of Earth's magnetic moment from the ground. And by the way, if you've got auroral imagery, hit us up on Twitter. Tag us on Twitter. We'll retweet. Next, real-time solar wind. It's been pretty steady here over the past about 12 hours. Current conditions are just under 500 kilometers per second for the solar wind speed. Solar wind density here at just under 11 protons per cubic centimeter. And let's continue on to the magnetic data section of the video. So we've got some pretty low readings here on the GOES magnetometers, as we do see a coronal hole high-speed stream continuing here. It's taking its time subsiding. That's the current state of affairs for the GOES magnetometers here. For the past 24 hours, we've seen kind of lower highs and lower lows on those GOES magnetometers. Next, looking at the heliospheric current sheet, we do have a bit of a magnetic tug-of-war happening over there in the east. At the moment, Earth is solidly in a North Pole-oriented current sheet depicted here in green. And we may be expecting to see some growth of sunspots or new rising sunspots in the northern hemisphere. Next, our line of sight field plot. There's what's going on in terms of our line of sight field plot. The solar B field is depicted here in blue. North polar field in green, south polar field in red. And let's move to coronal holes. We don't have any very well-defined coronal holes here at the moment. The main ones that are in the earthly portion of the solar disk, well, we do have a mix over there in the east. So let's take a look at that. Let's bring up the latest frame here first. There's the latest frame. So we've got a combination here. We've got some North Pole-oriented coronal holes around here. Let's see, that's north, and that's north. And then these down here, this is south. So let's just verify that's correct. There you go, some South Pole-oriented coronal holes down there, and some North Pole-oriented coronal holes. Coronal holes are super important when analyzing sunspot cycles, as they show us the solar polar field reversal process, a process that we are in the process of explaining through plausible astrophysics mechanisms. Anyway, if you want to read about that, become a gold member of the Smash Team at smashomash.com/Smash Team. Let's move to sunspots next. And that is a lot of sunspots. Again, we expect to see the number grow here because it is based on the number of umbrae. In other words, one tiny sunspot actually counts as 6 sunspots, I believe it is. And I'm not going to get into how that works. After all, this is the daily space weather video, not in-depth analysis of heliophysics. But anyway, this is what's going on. Likelihood of major flares, incredibly high. We sort of expect to see some X-class flaring. Continuing on to look at that in a visual perspective. Here's SDO continuum for the past 24 hours. Again, this group has shrunk. This group down here has grown. This group here has also grown, and we've got new sunspots forming, rising over here. So yeah, expect the sunspot number to continue to rise. Also, expect solar flaring to continue to rise, and the radio flux. I would expect that to be up to about 230 solar flux units by the end of the day today. So we've got more rising sunspots than we do setting or evaporating ones. So here's a little closer view. This is 94 angstroms plus SDO continuum, showing you all the bright regions there. And let's subtract 94 angstroms. Yowzers. That is some good stuff. Next, let's look at energetic particles here. No relativistic particles, despite all those flares. Check out all the flares. No less than 6 M-class flares since yesterday. Again, no energetic particles there. No relativistic protons showing up, despite all of that flaring. So maybe a little bit surprising there. And by the way, don't be surprised to see X-class flares. This is our deabsorption regions prediction, part of the Space Weather Prediction Center. And this will show you the attenuation of the D layer of the ionosphere. So when you do see a solar flare happen, it will cause high-frequency radio blackouts. And you can view this happening in somewhat real time by looking at the deabsorption predictions. Expect major high-frequency radio blackouts on an ongoing basis here because, well, major flares are highly likely. So we're just going to let that play through to show you the most recent locations of radial blackouts. Of course, you're going to see more of those south of the equator than north of it, since it is indeed wintertime in the northern hemisphere. The D layer of the ionosphere is the lower layer. It is at a lower altitude than the F layer. That's the most recent activity there, and of course the sun is at a significant C-class background radiation level. And let's take a look at solar flaring here from a few different wavelengths. There's 94 angstroms, and that is the last 24 hours. Here's 131 angstroms. Here are those wavelengths combined. And let's take a look at some of these active regions. So that sunspot group there, that has shrunk a little bit since yesterday. It's still certainly capable of producing major flares. We'll show you the high-resolution field imagery toward the end of the space weather section of this video. Here is a southwestern limb. Hulk Hogan filament there showing up as a dark absorption feature. And, of course, some flaring sort of spontaneously happening here. Just a bit of a plasma outburst there. No major active region, just a spontaneous flare happening there. One of the many indications that you don't need sunspots to see flares, you don't need flares to see coronal mass ejections, etc. Don't get the different phenomena confused, folks. There's a lot of different stuff going on there, and nobody's fully sure of the ultimate cause and effect. Although some of us are zeroing in on how stars actually work. So there's the spectacular eastern equatorial region. There's likely, in fact, you can actually see some plasma bridging here crossing the equator. That is a turbulent region, as this plasma out here is moving at a very, very high speed at the solar equator. Yeah, the sun, it's rotating faster than Mercury's orbit. That material is moving at a very high rate of speed. And let's take a step back and look at a star chart. If you're up before dawn, you might see Mercury. That's where it is now, just rising over the southeastern horizon there over Lehigh Valley, Pennsylvania. You may also see the moon in Virgo. And let's do a solar system forecast. Here's where heavenly bodies are today. We'll advance this 1 week for your astrographic pleasure. Here's where things will be in a week. Astrography, a study of the locations of things in space. In 1 week, we'll have a crescent waning moon as we approach February's new moon. Next, let's take a look at coronal mass ejections. So we've got a bunch of missing data here, unfortunately. We won't let that stop us, though. So let's take a look at the stereo A and SOHO LASCO C3 imagery. So in short, we've got some CMEs, mainly this one, which is on the far side of the sun. For you new viewers out there, congratulations on realizing the channel exists. Earth would be off on this line from the perspective of stereo A. So as you can see, a CME coming out of this area is definitely not earthly directed. It's the only major one that we see on the imagery. So let's take a look at some 24-hour videos of that light show, which is little more than that. Those are not headed toward your doorstep, unless your doorstep is on the other side of the solar system. And of course, leave us a comment if you're viewing the video from a different timeline, solar system, reality, plane of existence, planet, starship, galaxy, universe, multiverse, etc. Let's zoom in a little bit closer. That is good times. Next, we'll talk about filaments because the likelihood of additional coronal mass ejections is nearly 100%. Again, remember, folks, you don't need to see sunspots or solar flares to see coronal mass ejections. These are separate phenomenon. So here's what's going on here at the moment. That is the ground-based Cerro Tololo, Chile Hydrogen Alpha Solar Observatory. And the Hulk Hogan filament here is very well named. So shout out to Nay. Good job naming that filament. That is quite a large, dense filament there, much like Hogan's 24-inch pythons. Next, this filament here needs a name, and it probably wouldn't hurt to name this one. Also, this crown prominence up here could use a name. So a bunch of filaments could get named, and we invite all of you to join us on Twitter to do so. So if you haven't checked out the Twitter account, you're invited. By viewing this video, you've been invited to name that filament. Since filaments are a super important portion of space weather, don't name this one, but name some of these other ones because, well, they are quite lively and active. So we need names for those filaments. Will the Hulk Hogan filament eject soon? Let us know in the comments what you think after you press the like button. Because we'd like to stream live for you on YouTube. We just refuse to do it until we see a video with 50 likes. So yeah, follow us on Twitter if you don't have an account on the pathetic junkware platform rife with censorship that Elon fixed absolutely nothing regarding censorship on. Of course, he exposed the censorship, but he didn't fix it. That would be like equivalent to seeing a crime happening and just allowing it to continue to happen despite purchasing the crime scene. Anyway, the Hemp Lucid free gummies giveaway remains pinned on the Twitter feed. There's no shipping. There's no credit card required. If you want to try out some of the Hemp Lucid gummies, check out the Twitter page at Smash-O-Mash. All over the internet at Smash-O-Mash. Yes. Here's the past 24 hours in the house favorite wavelength. It's 171 angstroms ionized iron. The sun just texted us and said, I am Iron Star. I don't know what that means. Maybe that's some kind of a Black Sabbath reference. Anyway, here's the past about 2.5 hours in ionized helium here from GOES 16 SUVI. And check out this crown prominence. It is quite significant indeed. That is a good one. That one should get a name. And let's shrink that back down to show the full disk and move on to our bonus feature segment. That will start out as it does most days with satellite charging hazards, of which we've got some minor ones here moving into the Central Pacific Ocean. That's not going to cause very much of an uproar. Minor charging hazards there for satellites in the Central Pacific Ocean. The GOES electron flux here has dipped as we see a coronal hole high-speed stream continuing here. That dip probably caused by a little uptick in the solar wind density, but hey, who can really conjecture about that? It's pretty hard to tell what's going on chemically at the F layer of the ionosphere where the electron flux is measured. There's the forecast model. NOAA expecting flat levels of electron flux here for tomorrow. There's the one-year graph to put it in context. And we'll take a look at the vibrational frequency of that layer of the ionosphere, the F layer. By the way, this map shows the D layer that we referenced earlier. That is the D layer ends at the upper portion of the mesosphere. That is the boundary between the thermosphere and mesosphere. And we'll show vibrational frequency and anomalygram. So there's a vibrational frequency. That's megahertz, millions of vibrations per second. It's the bridge between Earth and space. So as we zoom into our meteorology segment, we keep bringing space weather closer and closer to your head. So again, that's what's going on in terms of vibrational frequency. We've got some significant anomalies here, especially the low frequency variety. South Atlantic anomaly remains looking like it's fixed over the South American continent. So we documented it moving thousands of miles on previous videos. It even made it onto our thumbnail. And by the way, our thumbnails contain more relevant factual information than entire channels that cover space weather. Since our channel lacks propaganda and nonsense and misrepresentation of science papers. Anyway, that's your anomalygram. And here's your latest image, 11:45 Universal Time. And there's the anomalygram. Vibrational frequency in megahertz, anomaly in megahertz from a 30-day median. We'll also take a look at the electron flux, the total electron content rather, the free electrons between the inner portion of the outer Van Allen belt where your GPS satellite is located, down to about, well, from your ground level to about 12,500 miles of altitude. So these are the most likely places to see GPS errors. And we're seeing surprisingly large amounts of GPS errors here, despite seeing higher levels of electron flux. So that's a little bit surprising. Also, some low electron content anomalies over the Caribbean and southern South America. Also, portions of the mid-latitudes here. Some oddities in our electron content here. So some anomalies happening there. Some major GPS errors in perhaps unexpected locations. Turn on your Wi-Fi accuracy if your GPS is expected to show massive errors. It'll help you navigate. If there are Wi-Fi hotspots, the IP addresses and known locations of those can help you to navigate. We'll close out the space weather portion of the video with our latest intensitygram and latest SDO magnetogram. So probably the most magnetically complex sunspot group is this group up here. So let's take a brief look at this group. Even though it has shrunk since yesterday a little bit, it is still beta gamma delta class. And the likelihood of it producing an X-class flare is high enough to state on this video. Great field complexity there. Don't be surprised to see an X-class flare from that group. And second would be this group down here. So this group down here also very magnetically complex. It's actually two sunspot groups there. It might even be three sunspot groups, but certainly at least two sunspot groups. And you can see all those different magnetic fields there. The leading group certainly beta gamma delta class, the trailing group beta gamma class. Anyway, here's the full disk rock back. As it is time to do meteorology and chew bubblegum. And we're all out of bubblegum. Before we do that, a reminder to press the like button, as the video cannot continue until you press the like button. Just kidding, folks. The video will continue. And of course, the beauty of video on demand is that you can watch the content whenever you like. So if you don't attend our live premieres, well, more power to you. Visit our homepage at smashomash.com and help us out with clicks. You can find a permanent link to the Discord chat, to the Instagram channel, the YouTube, the Hemp Lucid, etc. Smashomash.com. It's the official homepage of the Smash News Network, least busted name in news. You can also find links to the Hemp Lucid shop, like I said. And if you click the link, here's what you'll find. It's your last chance to save 20% on orders over $125. That ends tonight. Again, check out the Twitter feed to find the link to the free samples of mushroom gummies. Thanks to everybody who's picked them up, the Shop Buy Solution, etc. Let us know if you've tried out any of the Hemp Lucid products. And again, thanks to all of our YouTube subscribers for tolerating the pathetic, putrid, and disgusting censorship on the platform. We insist that you big tech organizations fix your software. Centralization and censorship are dead, so please enter into the modern world. Shut off the shadow ban features. Just eliminate all of the deboosting and allow people to communicate via their merits. Press like, press subscribe, press share. Tell your friends and foes about the channel, since we don't seem to think YouTube recommends the content. Also, check our playlists if you haven't checked those out. You can even find things like recipes on there in our Ownage Food and Drink playlist. Have you heard the 12 Days of Smashmas? Yeah, we released original music on the first 12 days of December, and now we are in the realm of meteorology. So check it out. We're looking at the Southern Ocean here and the sea surface temperature anomaly and currents. So that's what you're looking at. The moving portions of that, those are the currents, and the colored portion is the sea surface temperature anomaly. So a little mix there of both high and low temperature anomalies there in the Southern Ocean. How about the Arctic Ocean? More high than low temperature anomalies happening up there. Also, we'll take a brief look at the Gulf Stream. You can see the Gulf Stream continuing to make it up there in warm places like Ireland and Iceland. If you're expecting a year without a summer in Europe, guess what? You're not going to get one, because the Gulf Stream is still doing its job. The east coast of the U.S. actually anomalously cold there. Check out all the cold water all around the Gulf Coast and all the way up to Maryland, really. Also anomalously cold water there around Cape Cod. Interestingly enough, Lake Michigan and Lake Huron are anomalously warm at the moment. Equatorial Pacific Ocean remains very cold, and the northern Pacific here cooling down also. New Zealand surrounded by hot water, not just by their weird government, but by it's literally hot water. Anyway, northern Indian Ocean also cooling down, becoming anomalously cool here. Southern Indian Ocean anomalously warm. And anyway, that's what's going on in terms of sea surface temperature anomalies and currents. Let's take a look at wind. A lot of channels on YouTube that attempt to cover space weather and meteorology blow. This is how the jet stream blows over the eastern portion of the planet. And if you had to pick only one piece of weather data to forecast global weather patterns, the jet stream would be a good call. These are the surface winds of this side of the planet. Some strong lows there around Australia. These are the surface winds of the Western world. Shout out to our viewers from all around the planet. Who knew we'd make so many pals by citing facts about nature on YouTube? These are the jet streams of the West. Tripled up jet stream over the northern Pacific Ocean there. Doubled up jet stream over the North Atlantic. Jet streams of the central world depicted here, and these are the surface winds. Here's some more real-time data, or nearly real-time data for you. It's the NASA GOES Interactive Weather Satellite Suite. The 3.9 nanometer infrared radiation map shows clouds and fog when it's too dark to use the visible satellite. And you can see the sun rising there. It looks like a shadow. It's because the satellite has to interpret that data differently since it changes the radiative profile of the imager. That's what's going on. Here is your weather.gov map. So we're expecting some strong winds, not only around Hawaii, also around Alaska, around the Texas Gulf and Louisiana Gulf coasts, southern Florida, and up the east coast of the U.S. If your location's lit, click your location on your weather.gov map, and let's do some forecasts. So we've got a low pressure here forming over Florida at the moment. It's going to move up Georgia and South Carolina, and then leave the coast around the Outer Banks. That's your pressure and precipitation forecast for the next 72 hours based on the GFS model. Next, your 10 meter wind in knots and mean sea level pressure. It's the same model, the GFS 72 hour. So we decided to show wind there since there are some gale warnings and so on up the East Coast. Also some windy times coming to the Great Lakes. And we'll also show the temperature anomaly forecast since we've got anomalously warm temperatures continuing in the Boston to DC corridor. That's your temperature anomaly in degrees Celsius for the next 72 hours. Again, based on the GFS model. And thanks for leaving a comment, Mike Bordages. Good morning to you as well. So next we're looking at pressure here. This is our windy.com map. One of the great features is pressure. That's just the Euro and the GFS models. We won't show a forecast here at this point. Let's just move on and look at a lightning mapper as we have had some heavy lightning here in the Gulf of Mexico. Also some significant lightning there in Florida and Alabama, it looks like. Let's see if we've got any terrestrial strikes at the moment. Just some rather heavy thunderstorms there toward the western side of the Gulf. And an active cell there south of Nolens. Also south of Pensacola, some thunderstorm activity out there. Here's a full zoom out. Next time you hear thunder, check it out. You won't regret knowing where the lightning is striking. It could save your bacon. And we'll close out the video with some more real-time data here. And let me just take a brief moment to zoom in at the lower 48 and show this little spot right here. So if you think that's where the HARP base has turned off their HARP, or if you think that's where the chemtrails have ended because of this straight line that you see here, that's where the Doppler radar ends. It can't see past there, and so there's no data for that area. It's nothing unnatural whatsoever. It's the end of the range of the Doppler radar. By the way, that's radar.weather.gov if you're wondering. Here's shortwave radiation showing clouds and fog. A large bank of low clouds here over the western Atlantic. And here's your water vapor map to close things out. That should clarify some stuff. There's some rapid cloud nucleation happening here in the Gulf. Here's your recap. That's vertical motion of water droplets and ice crystals. This is 3.9 nanometer radiation, part of the infrared spectrum from the interactive NASA GOES Weather satellite suite. And there is water vapor. And here's me closing out the video. So once again, if we get 50 likes today, we will do a YouTube live stream. So make sure you press the like button, share, etc. Thanks everybody for tuning in and tolerating the pathetic censorship all over the internet. We would remind you that centralization and censorship are dead. So enter into the real world, big tech organizations, and fix your junkware, we insist. There is no alternative to Google, Facebook, and Twitter. There is no alternative whatsoever. I don't care what alt tech sites you use. There is no alternative. And so if you're going to maintain your monopoly, you're going to have to run it in a fashion that allows people to have their content seen. So anyway, good luck with that, big tech organizations. In the meantime, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.